So, welcome back to this decision analysis under uncertainty lecture notes. And now we are in a final section of the chapter 3, decision matrices and rules. And in this section, we consider combining decision problems. So the idea is, why do we want to combine decision problems? Well, the obvious example is that we have two decision makers and they want to make a compromise. So they both have their own setting for the decision making and they both choose their own optimal value. And if they are different, then the question is, can we somehow negotiate a compromise rule that is good for both? And to combine two decision problems, what is needed is only need the respective value functions. So the scenarios can be different, but the alternatives must be the same. And to combine two value functions, we have to have two things in mind in order to do it. So they have to be the same type, so both maximization or minimization. We will choose a maximization in this course, and then they have to be on the same scale. So a minimization type value function, if the one of the or both of the value functions we want to combine are minimization type, we have to transform it into maximization type. And this is easy. You just multiply something by -1, so then minimization becomes a maximization. So this is a simple transformation. A slightly more complicated transformation is the scale transformation. So the value functions must be on the same scale. It cannot be so that the other measures in milligrams and the other measures in kilograms, for example. You immediately see that they have to be on the same units. So if there are no units, then they have to be somehow on the same scale. And how are they in the same scale? Well, there are many ways of scaling functions. What we use here in these notes on this course is the so-called affine scale transformation. So we take the value of the v, subtract the minimum, and divide it by the maximum minus minimum. So this is the new vi. So vi minus the minimum over minimum of vi's divided by maximum of vi's minus minimum of vi's. And once this happens, then the value function vi, this new value function, will be in the interval 0, 1, so that the best value will be 1 and the worst value will be 0 in general. Of course, there's a slight problem if the value function is constant, meaning the maximum and the minimum of vk's are the same. We have a division by 0 problem. Actually, we have 0 divided by 0. What is that? And in this case, in this course, 0 divided by 0 is 1. All right, this choice works well. And then in your exercises, assignments, you have to do this affine scaling when you do the compromise or combine the decision rules. And for your convenience, I have done a GNU octave function scaling that does this affine scaling automatically, and it can be downloaded here. So you don't have to do this scaling manually. And also there will be some M files later on in these notes, and almost all of them use the affine scaling function scaling, so it's a good idea to download the file scaling.m to your GNU octave working directory now, if you haven't done it so already. And then I should know that there is also another GNU octave function that is used repeatedly in the M files in this booklet. It's called dmatrix. So that solves the decision matrix problems automatically, so you don't have to do these calculations that were in the previous sections in this chapter. So those also are done automatically by this function called dmatrix. All right, let's get back to combining decision rules. So now we have v1 and v2, so these are not v to power 1 and v to power 2, they are super indexes, so value function v1 and value function v2. There are two value functions. We assume that they are both maximization type and both are affinely scaled to the same scale. So how do we combine them? Well, we choose a so-called compromise parameter w from the interval 0, 1, and combine these value functions v1 and v2 into new combined or compromised value function v that depends on this w. So how it goes, this is similar to Hurwitz rule. We take the combination where we multiply v1 by w and sum 1 minus w times v2. So the combined value function v of w is a compromise of v1 and v2, where v1 is given the weight w and v2 is given the weight 1 minus w. Now the question is, what is the w? In principle, it can be anything. Of course, it then depends on how do you want to combine. If you have two equal parties, then w equal 1/2 is the obvious choice. And sometimes you want to give an unequal weight, so 60% to other one and 40% to other one. This can be done, and then the w is the 60% and so on. So that was all on chapter 3, and see you in next video lectures. Bye.